Hello, my name is Vincent Liu, and I am presenting my project for the class CPSC 6899 for spring 2019. And this is for the class Real-Time Human Pose Detection for 3D Game Design. I wanted to go over the application that I had built for the project. And the goals of the application is to create a game application that relies on human movement as interface to drive the movement of the 3D game character. In order to accomplish that, I needed to use AI machine learning techniques along with computer vision concepts to predict on webcam input, basically input that's being captured by the webcam. And this would be done using the PostNet model developed by Google. The game itself is a 3D game, moving it within the X and Y coordinate, and it uses the latest 3D browser rendering technology. In addition to the game graphics, there are 2D data visualizations as well, provided to kind of render the model decisions. So it better kind of provides insight into how the model is processing the webcam data that's coming in. And how the game, which is called Shape Runner, works is that the browser allows the webcam to be used after the user accepts permission. And then once they start the game, the webcam then captures the video feed of the player's movement and passes it to the PostNet model. And the further the person stands from the camera, and the more of the body pose the camera can get, it will make better predictions. And the model makes predictions on the images that's being stripped out from the webcam itself, the webcam input. And then the output of the predictions are the current predicted positions of the player. So wherever the player is moving their arms, the key points of the joints, it's making a prediction on each of those key points in terms of the X and Y coordinate, along with the various confidence levels of its predictions. And as the coordinates are being picked up, they're converted into 3D character positions so that we could drive the movement of the 3D character in the game. The game itself ends either when the timer runs out during the round, or if the player gets hit 3 times by squares that are moving randomly towards the player itself. So within the application, there are 2 different modes. There's the game mode, where the actual gameplay and the 3D character and world is kind of shown. And in the game mode, there are specific data visualizations like graphs and various spatial visualizations that represent the webcam input and being predicted by the user's movements. In the test mode, however, a video is used as the model input instead. And the basic goal of test mode is to really test the video's accuracy in terms of getting predicted by the model itself. And it also uses similar visualizations to kind of output, how the model is thinking based on its decisions along the way. But there is one specific data area that it encapsulates a little more visualizations versus game mode. The layout of game mode itself, how the screen and everything is set up, is based on the game world screen being the top of the screen. That's where the 3D character is. And then below that is a webcam canvas output, which showcases the webcam input being captured, along with the body pose estimations. And so I'll kind of run through game mode itself here. So if we look at it, this is the start of the app. If we go to the website, as you can see, this is the game world itself where the 3D character is, and you can adjust the camera angles a little. And then again, there's 3 buttons, each correlating to the different modes. Start test mode would have triggered the test mode itself, whereas start game would have started the game. So if we start the game, you can see that based on my movement, I can move the character itself and dodge, and I got hit twice actually. But if you see, the further back I move, the more the camera angle can capture more of my movement. So as you can see, it can move more of my joints to dodge the boxes that were flying at me. And so if we pause the game right now, we could see that there are 3 visualizations that are key to understanding how the model works. First is the what is called the webcam canvas output with body pose estimations. And so this is what is captured in the webcam itself. And as you can see, overlaying it, superimposing over it, is the body pose estimations done by the model. And then if you see right next to it, there's the exact same kind of body pose estimation, but this was the next adjacent canvas, and it has the grids and axes along with the X and Y coordinate planes to kind of capture more of what coordinates the model thinks each pose is at, basically. And so this gives a more accurate depiction of the positioning. And then far below that, you can see that there's a bar graph, each with the 17 key points that the model itself predicts on as the output metrics. And with each of the category, you see that there's a range of between 0 to 1. And that's basically the confidence level, the amount of confidence the model has on the prediction of the X and Y coordinate for that particular key point. And as you can see, it fluctuated during the movement itself, because as I move around, the accuracy level of each key point kind of goes up and down based on where I'm at and how I'm moving and how the model is picking it up, basically. And then, so that's the game mode itself. So if we go to the test mode, the difference is that, again, the video player is really being shown versus the game world itself, and it plays a video in a loop. And so if we go to that right now, and I click on start test mode, you can see that a video itself is being played. And then let me zoom out a little. So you can see that the video player is being played, and it's playing a kind of stock video, a generic video in a loop. So it's constantly moving. But as you can see, 3 of the screens display is really the same. You can see right here that the body pose estimations are still superimposed over the webcam input canvas. And then the actual body pose estimations is done here as the character moves and the grids come in. And additionally, again, the 17 key points are predicted on based on the confidence level of how strongly the model believes its values are accurate for each particular key point prediction. And for each part square accuracy, I decided to also output it here. The difference of why I didn't do it in the game world is that I felt, as you were moving, it would be hard to pick up on these data points as the game was going on. So this felt less burdensome for the user. But these are the key differences. And so as we talked about, again, the canvas being the video output versus the webcam input, and superimposed is still the body pose estimations. And then the grid, again, is showing up as well, along with the bar graph. And again, the side panel is what's different, and it displays the actual confidence level value. Several kind of browser rendering and serving technologies were really used, and it drove the 3D game animations along with the environment setup. 4 of them, the key one being JavaScript itself. That's the main programming language or scripting language that was utilized to build the application, along with building the serving technology for it. WebGL was heavily used in the back end of things, and then 3JS was an abstraction above it. And both of these kind of played a role into how the 3D animations kind of got rendered. And finally, the Webpack library was utilized to serve the application locally during development, and also played a role in building the production deployment version of it. And I'm going to go into each particular one and how they kind of incorporated it into the application's development. So WebGL, again, WebGL was kind of underneath everything, but it played a big role because it's the main JavaScript API for rendering interactive 3D and 2D graphics. It utilizes the graphics processing unit, or the GPU, to process the graphical updates. And that is much faster than using Canvas alone, which is mostly the normal default if WebGL wasn't supported by a particular browser. And using the CPU or central processing unit is slower because it has to calculate each frame more intensively, and it also kind of puts too much burden on the CPU, whereas the GPU kind of deals with that much quicker, and processes the frames much quicker and faster than the CPU. It also conforms to the OpenGL ES 2.0, which is used for mobile devices as the main graphic renderer. So it's fast enough that it could be processed by a lower processing unit, like a mobile device, like a smartphone. And it drives much of the graphics in the 3D game world. And consequently, in this project, it also powers a lot of the machine learning process, as we'll go into later on. 3JS is really an abstraction above WebGL. It's a library that provides API calls that will allow for managing 3D graphics much more easier. But on its backend, in its code itself, it's really doing WebGL calls. But it simplifies the number of calls we need to make. It makes things much more componentized and manageable. But it still relies on fundamentally the request animation frame, which is a method that does an animation, along with updating it on a callback before repainting the screen. And that's the main driver of the frames per second kind of logic checks. Webpack is a configuration library that's built in JavaScript. JavaScript, and what it does is it takes JavaScript code that I've written in this application, which is ES6 version. I wrote it in that version, but it uses a library called Babel Loader to compile it to ES5, which is the supported one in most browsers. And then what it does is it also handles compression and concatenation tasks, and it provides a dev server for local development. And the other main thing underneath everything during development is that what it really does is it imports files and assets and creates a kind of dependency map that allows for module development in JavaScript. So you can import files, and Webpack will know how to find that file and incorporate it when it starts to build it for a production deployment. And that's the key step that it does. In order to serve it, it concatenates and builds one compiled version of the application to be hosted statically. And then the other key technology, outside of browser rendering is how to get the webcam stream, right? A webcam is usually, whether it's connected to the computer or it's an external webcam, from the browser's perspective, it uses the same API, and it's called the Media Devices API. And it's provided by a JavaScript, and it's supported across most browsers. And usually each browser does its own version of it based on how it implements it. But the general method of get user media is generally utilized. And what that method does is it gets the audio and video together and streams it into an object that could be processed, basically. In terms of the data visualizations, the key visualizations being driven are driven by the libraries D3JS in terms of the bar graph with confidence levels changing, and then the TFJS visor, which showcases the table showing the same values. And also using D3, I also did canvas spatial visualizations using the canvas output, basically. And this was done during the canvas element, but D3 was incorporated with it to do the output of body poses, especially in the grids and in the video webcam output. Now, several visualization styles are in play in this application. One is the juxtaposition style, which tries to do multiple data instances at the same time, but using different areas of the layout, right? So as you can see, there were several kind of charts being utilized in both modes, really, and they kind of play a role of showing the same data but in different locations, and also showing different data at the same time. And the other kind of style that was in play was superimposition, which, like the grid here, and also with the video output here, we can see that it was two visualizations combined into one, and that's The other kind of data visualization style in play is spatial data and presentation spaces. In terms of the data that's being captured from the webcam, represents more of the independent data variable, and the output being the predictions on the actual positioning of the webcam data represents the dependent variables. And the presentation spaces are kind of like the colors, the styles, the different graphical elements that plays into the visual display of that data. And this could be seen with the game world along with the various 2D data visualizations that are done. And then the aspects of computer vision in play in the game and in general is that the convolutional networks is really utilized by the PostNet model. It's detecting edges and other image features, and with each layer in the neural network of processing, different features are being bottled up, and with different patterns being picked up, the overall output is combined into a layer at the end with the output. And midway, strides, padding, and feature maps, and the different sizes of each one being implemented plays a role in helping to tailor the accuracy of the model. And then PostNet provides configurations to allow for customizing the performance and accuracy of the model predictions. And in terms of the AI machine learning model, PostNet, PostNet was developed by Google, and it's based on the mobile net model, which also makes predictions on mobile devices. What it does is it makes predictions on the body poses with each image frame being picked up in terms of the webcam or the video player. 17 different key points are outputted, with each having a prediction of the XY coordinate of each position and a confidence level of the prediction itself. And the way to run the PostNet model in JavaScript is done through TensorFlow.js. It's based off of TensorFlow, the machine learning framework in Python that's also developed by Google. And it's a library that provides API tools to import, manage, modify, and use machine learning models. Whether you could train it with TensorFlow.js or importing it through transfer learning. In the case of the project, the PostNet model was imported into a library, and the API provided can also convert video stream into images that the model can predict on. In terms of the application, how it was hosted on the website, this was done through Amazon Web Service. It's a cloud provider that Amazon provides. And the services that were provided includes tools to help provision virtual servers using virtualization for hosting various applications. Through this way, it was cost effective because it allows servers to be shared by other applications. This was all managed by Amazon, including the hardware, the cost of maintaining the hardware, and also making sure there was no downtime. This left developers like me focused on the application versus setting up servers. The services that were utilized were Amazon EC2 primarily. It's a web service that allows for provisioning virtual servers. And then the other key service that was used was CloudWatch to help set up monitoring and maintaining the server performance and health. And various configurations set up were used to make the application run in HTTPS protocol. And then finally, I took the EC2 instance public DNS and I connected it to my domain at HTTPS vincent101.com, and this was done through Route 53 as well, which is another service provided by Amazon. And then finally, Nginx was also utilized to make the application proxy serve correctly. Nginx is a proxy server that acts as a middleware routing system. It transfers network traffic from one port to another and from one URL to another if needed. For me, I needed to run HTTPS at 443, but I wanted to keep the original port for the application as it is. And so I used Nginx to route the traffic to that original port. And this was done through accessing the specific website here with the specific path. And in the process, Nginx also caches the resources And this lowers the amount of time needed for the next load, and this would have been cached the first time. I want to say thank you again. It was fun working on this project. Thank you to Dr. Lee for providing his guidance. And the application is served through the URL here. And thank you for listening to my presentation.